morning, everyone. I am Mahima Saxena, Assistant Professor at AKGEC Department. Today, I'm gonna teach what is functional dependency. Basically, a functional dependency is a relationship that exists between two attributes. It typically exists between the primary key and the non-primary key attribute. Now, what is the primary key? Primary key is basically a key that identifies value uniquely. For example, I have a table of student. The data related to student is stored in that particular table. Now I need to identify some student name XY, his address or his basically his details, his contact details. Then I will search in this table with the help of his or her roll number. The roll number is the primary key for that particular table. This is called a primary key. Now in functional dependencies, we always write in this form x determines y. Now x is generally a primary key or subset of a primary key, and y is non-primary key attribute. The left side of functional dependencies is known as a determinant. The right side of the production is known as the dependent. Basically, dependent is determined with the help of determinant. For example, we have an employee table with the attributes employee ID, employee name, employee address. Now, here employee ID can uniquely identify the employee name attribute of employee table, because if we know the employee ID, then the name associated with that employee ID or all the information associated with that employee ID, we will able to find it. Functional dependency can be written as employee ID determines employee name. Now, two types of functional dependencies is present. First, in this subject, we need to study two types of functional dependencies. First is trivial functional dependency. Second is non-trivial functional dependency. Now, what is trivial functional dependency? A trivial functional dependency in DBMS occurs when an attribute or a set of attributes on the left-hand side of a functional dependency already determine the attribute of the right hand side without any extra information. For example, if I have a dependency A determines B, then the next functional dependency is B determines B. This is known as a trivial functional dependency. Basically, we do not need to do extra efforts for finding that particular attribute, because A is already determining B and B derives itself in this scenario. This is called the trivial functional dependency. The next is, consider a table with two columns, employee ID and employee name. Employee ID and employee name. Employee ID is a trivial functional dependency because in this example, employee ID and employee name determines employee ID. Now, employee ID can already determine itself because any attribute can always determine itself. This is the example of trivial functional dependency. The next is also employee ID determines employee ID and employee name determines employee name. These both are the example of trivial functional dependency. The next is non-trivial functional dependency. In non-trivial functional dependency, the dependency is strictly not a subset of the determinant. In the previous trivial functional dependency, basically the attribute is already the subset of the determinant. But in this functional dependency, non-trivial functional dependency, determinant is not a subset of, basically dependent is not a subset of determinant. That is, X determines Y is not a subset of X. Then it is called as non-trivial functional dependencies. A determines B have a non-trivial functional dependency if B is not a subset of A. When A intersection B is null, then A determines B is called as a complete non-trivial functional dependency. Example is ID determines name and name determines date of birth. The next topic is inferences rules. These are the inferences rules that we are used. Basically, different types of inferences rules are present, and we use to find out the different types of functional dependencies. The first inferences rule is also called as Armstrong's axioms. Armstrong axioms are the basic inferences rules. Armstrong axioms are used to conclude functional dependency on a relational database. The inference rule is a type of assertion. Basically, it can apply to set of functional dependency to derive other functional dependencies. With the help of inferences rule or Armstrong's axiom, we apply these Armstrong axioms or inferences rule on functional dependencies and derive other functional dependencies. Using these inferences rules, we can derive additional functional dependencies from their initial state. Now, what are the other inferences rules? The first one is reflexive inferences rule. In a reflexive inference rule, y is a subset of x, then x determines y. Basically, x is a subset of y, then x determines y. For example, I have value x is a functional dependencies, and we have these elements a, b, c, d. Then y determines a, b, c. This is called reflexive functional dependency. The second one is augmentation rule. Augmentation rule is basically I have attributes x and y, and we augment z on both sides. Basically, we have an attribute, for example, and we will amend. Basically, amend means adding an object, adding an attribute in both the sides. This is called augmentation rule. The augmentation rule is also called as partial dependency. In augmentation, if x determines y, then xz determines yz for any z. This is the example of if x determines y, then basically we augment z on both the sides. Now the example is for relation R A, B, C, D. If A determines B, then AC definitely determines BC. This is the example of augmentation. The third one is transitive rule. Now, what is transitive rule? If x determines y determines z, then x determines z is also applicable, is also right. This is termed as transitive rule. In the transitive rule, if x determines y and y determines z, then x must also be determined z. This is called transitive rules, and we further discuss about these rules. Then the fourth one is the fourth Armstrong axiom or inference rule is union rule. Basically, we are combining different attributes. The union rule says if x determines y and x determines z, then x also determines y and z. If x determines y and x determines z, then we perform union of x and z, then x definitely perform y and z. Basically, definitely derives y and z. The proof is we have x determines y and x determines z, then x determine x, y using R2. Basically, augmentation rule. With the help of augmentation rule, we amend x, and in the next we augment y in the second with the help of augmentation rule, and with the third x determines y, z. This is called the union rule. The next one is decomposition rule. Basically, what is the meaning of decomposition? Decomposition is a decomposed anything, like decomposed in small parts or small attributes, whatever it is. Basically, divide in smaller parts. Divide the object, divide the class, divide the attributes in smaller parts. Now, what is decomposition rule? Decomposition rule is also known as project rule. It is the reverse of union rule. In union, we are combining two attributes. In decomposition, we are decomposing. We are dividing one attribute into two or more parts. This rule says that if x determines y and then x determines y and x determines z separately. Like basically, x determines yz, then x determines y and x determines z. We decompose yz into two different functional dependencies. This is called decomposition. The example of this is x determines yz. The other one is z determines y with the help of first rule, reflexive rule. Then x determines y with the help of third rule. And so this is the complete example, and this is the proof of decomposition rule. Now the sixth one is pseudo-transitivity. Now, what is pseudo-transitivity? It is kind of similar to transitivity. In pseudo-transitivity rule, if x determines y and yz determines w, then xz determines w. Basically, we have one functional dependency, x determines y and yz determines w. Then xz determines w also. This is called function pseudo transitivity. The first one is basically the proof is x determines y, yz determines wy determines z. These are the given. Now with the help of augmentation rule, I applied x and y on both first side and y side, and after using the third and second inference rule, wx determines z. This is called the pseudo transitivity rule. These are the 6 Armstrong's axiom or inferences rules that we are used in functional dependencies to determine or to find out other functional dependencies. Now the next topic is normalization. Now what is normalization? This is the most important topic in DBMS. Like a large database defined as a single relation may result in data duplications. Basically, we have lots of data, and in data we have duplicacy also, missing values also, and different types of errors are present. This repetition of data may result in many relations are very large. It is not easy to maintain and update data, as it would involve searching many records in relation. Wastage and poor utilization of disk space and resources, the likelihood of errors and inconsistencies increases. So to handle all of these problems, we should know about, or we should analyze and decompose the relation with redundant data into smaller, simpler, and well-structured relations that are satisfied desirable properties. Basically, normalization is a process of decomposing the relations into relations with fewer attributes. Basically, now in this topic or in this process, we are decomposing the relationships into smaller parts, basically on those relationships that we are interested to perform some query, or we are interested in performing some applications or operations, whatever it is. Now, what is normalization? Basically, normalization is a process of organizing data in the database according to our need, according to our requirement. We are organizing data. The second one is normalization is used to minimize the redundancy from a relation or set of relation. It is also used to eliminate undesirable characteristics like insertion, updation, and deletion anomalies. Normalization divide the larger table into the smaller and link them using the relationships. Basically, we are normalizing the data. Basically, normalization is doing like dividing our large set of data into small subsets and link them with the help of relationships. Now, the normal form is used to reduce redundancy from the database table. Why do we need normalization? The main reason for normalizing the relation is removing these anomalies. In previous slide, I'll explain what are the anomalies, like insertion, deletion, updation. These are the anomalies. With the help of normalization, we remove these anomalies. Now, failure to eliminate anomalies lead to data redundancy and can cause data integrity and other problems as the database grow. Basically, जैसे जैसे हमारा सिस्टम बढ़ता जाता है, हमारे पास डेटा बढ़ता है. जब डेटा बढ़ता है तो उसमें प्रॉब्लम्स बढ़ती हैं, और उसको हैंडल करने के लिए हमें ये चाहिए. Normalization consists of a series of guidelines that helps to guide you creating a good database structure that helps us, basically that decreases our time, that helps us to implement faster. Next is data modification anomalies can be categorized in 3 types: insertion, updation, and deletion. Now, what is insertion anomaly? Insertion anomaly refers to when one cannot insert a new tuple into a relationship due to lack of data. The next one is basically insertion anomalies. We have to insert a tuple and we have not sufficient data. We have a lack of data. Because of that, we are unable to insert any tuple into a particular table or relation. This is called insertion anomaly. Deletion anomaly is Deletion anomaly refers to the situation where the deletion of data results in the unintended loss of some other important data. Basically, deletion anomaly is a deletion. Basically, we are deleting of data. We are deleting something, and because of that deletion, some data will not be able to loss. This is called deletion anomaly. Next one is updation anomaly. The update anomaly is when an update of a single data value requires multiple values of data to be updated. Suppose we have an example of like in CSE department, we have one faculty member whose name is XYZ, and now he leaves the college. After that, the all the load of that faculty member will given to another faculty member. Now, instead of his place, we need to change his name. This is called updation anomaly. At every place, we need to change his name to the other new faculty member. This is called the updation anomaly. Now, what are the types of normal forms? Basically, in normalization, we have different types of normalized forms. Now, what are these? Normalizations work through a series of stages called normal forms. The normal forms apply to individual relations. The relation is said to be in a particular normal form if it satisfies the particular constraints or particular condition. For example, 1NF. In 1NF, a relation is in 1NF if it contains an atomic value. Now, what is the meaning of atomic value? Suppose I have a table, student table. If atomic values is known as like the values that are single, basically in 1NF, multi-value attributes are not allowed. If multi-value attributes are present, then we need to remove them, and after that this table or this particular data is in 1NF form. This is called 1NF. The second one is 2NF. A relation will be in 2NF if it is 1NF and all non-key attributes are fully functional dependent are all fully functional dependent on the primary key. Basically, in 2NF, partial functional dependency is not allowed. Now, what is partial functional dependencies? The first one is, first of all, we have a primary key. Primary key is try to find out the values of another key. Now, the primary key is, suppose we have AB is the primary key, and now for AB determines C and B determines D. B determines D is the example of partial dependency, and 2NF doesn't allow the partial dependency. After removing this partial dependency, we will conclude that the table is in now 2NF. If the table is in 2NF, then it is already in 1NF. Otherwise, simplest form of any table or any relation is 1NF. Generally, a table is in 1NF. If not, then we have to remove the multi-valued functional dependencies. After that, it will be in 1NF. Now, 3NF. A relation will be in 3NF if it is in 2NF and no transition dependency exists. Transition dependency is similar to transitive dependency. Suppose X determines Y, Y determines Z, then X determines Z. This is the transitivity, and this scenario is not present in 3NF. Now, the fourth one is BCNF, by Biose code normal form. A stronger definition of 3NF is known as Biose code normal form. Now, 4NF. A relation will be in 4NF. It is in BCNF and has no multi-valued dependency. This is called 4NF. Now, the 5NF. A relation is in 5NF if it is 4NF and does not contain any joint dependency. Basically, joining should be lossless. This is called 5NF. Now, the advantages of normalization. What is the advantage of normalization? Basically, normalization helps us to minimize data redundancies, greater overall database organization, data consistency within the database, much more flexible database design. The last one is enrolls the concept of relation integrity. These are the advantages of normalization. Now, the next one is disadvantage of normalization. You can start building the database before knowing what the user needs. This is the biggest advantage. You don't know the requirements of user and you are start building database. The performance degraded degrades when normalizing the relationship to higher normal forms, that is 4NF and 5NF. The performance will always degrade. Whatever you are performing, whatever data set you have, the performance will always degrade if you are normalizing relation to higher normal forms. It is very consuming and difficult to normalize relation of a higher degree. The next one is careless decomposition may lead to a bad database design, leading to serious problems. These are the advantages. Thank you so much for this lecture.